What is solar energy? Solar energy is the conversion of solar power into the electrical energy using photovoltaic cell. It can be defined as it is a method which is generating electrical power by converting solar radiation into direct current electricity using semiconductors. The solar cells are classified into three generations, right? First, second, and the third generation solar cell. Here, the first generation solar cells are having large area single layer PN junction diode. For example, monocrystalline silicon. The second generation solar cell, it having multiple layer of PN junction diodes. For example, polycrystalline silicon and ribbon silicon. Then thin film solar cells, such as cadmium telluride, copper indium gallium selenide, copper indium selenide, gallium arsenide. Next one is the third generation solar cell. So it having semiconducting device which does not rely on PN junction. So for example, dye sensor solar cell, organic polymer solar cell, and quantum dot solar cell, perovskite solar cell, comes under the third generation solar cell. The efficiency of solar cell to electrical energy conversion have reached maximum up to around 25% so far. So now among this third generation solar cells, four solar cells, we are going to see about the dye sensorized solar cell. Here, the dye sensor solar cell was first developed by Professor Greatzel and his co-workers in the year of 1991. He coined this solar cell device by mimicking the photosynthesis of the plant. So we know that in photosynthesis, the chlorophyll pigment absorbs the sun radiation from the sunlight. Using this energy, electron generation from chlorophyll. This electron is consumed for the preparation of plant food. So then the electron is replaced in the pigment from the water source. This is the full cyclic process of the photosynthesis. So in DSSC, this is the device of dye sensor solar cell. In DSSC, the dye absorbed TaO2. Here you see the dye absorbed TaO2 used as the photoanode, and platinum as the counter electrode, and triiodide used as the redox catalyst. The FTO glass plate is used as the current collector. Here, the mechanism of the dye sensor solar cell is the dye absorbed the photon from the sunlight and eject the electron. The electron traveled through the TaO2 and reached the FTO glass plate, and then it is traveled in the outer circuit and utilized by the source. Again, from the source, the electron reached as the counter electrode. From the counter electrode, it reached redox electrode through platinum catalyst. Now the electrolyte replaced electron into the dye. So if we this is the cycle process of the dye sensor solar cell. If we compare the photosynthesis on this device, you see here the electron acceptor of photosynthesis is carbon dioxide. In DSSC device, titanium dioxide. Then electron donor of the photosynthesis is water. For DSSC device, triiodide electrolyte. Then photon absorber in the photosynthesis is chlorophyll. Here in DSSC, it's a dye. So this is a easy comparison of the photosynthesis as well as dye sensor solar cell. It's a simple concept. Thank you.